Greetings, welcome to Self-Assessment Lesson 9, Problem 4b. So in 4a, what we saw is that we had two real solutions to our quadratic. And when we looked at the graph, we saw that it crossed the x-axis twice. And when we used the intersection routine, we were able to verify that those indeed, the numbers we got algebraically were the same as the ones we got graphically. So we're going to do the same thing here in this one. But this time we're going to find is that perhaps we don't have two solutions. So we'll see how that works out. All right, so first off, again, we need it to be in the form of ax squared plus bx plus c is equal to 0 before we go any further. So let's do that. So if we set this up that way, that's going to be x squared plus 9x minus an x, as I'm subtracting an x from both sides, plus 11 is equal to a negative 5. Okay, so that gets me a 9. Oops, no. What am I doing there? It's not a 9 yet. That's still an x squared. There we go. X squared plus an 8x. And then we subtract 5 from both sides here. And so we get 11 minus a negative 5, or 11 plus 5, which gets me back a 16. So I kind of said that a little chewy, but basically what I meant to say was add 5 to both sides, okay? And we get back to a 16. Okay, cool. All right, now hopefully you see that the factoring here would be pretty straightforward, and that 4 times 4 is 16 and 4 plus 4 is 8. And so the left-hand side looks like it's going to factor to x plus 4 times x plus 4, and that whole thing is going to be equal to 0. So we get what's referred to as a repeated root here. In other words, we get a repeat when we use the zero product property of x plus 4 is equal to 0, and we come back with just a single solution of x is equal to negative 4. All right, so they ask us to go ahead and verify that or check our answers on our calculator. We could plug it back into the equation, but I'm going to go ahead and, since we have the capacity to do that, we're going to check that out graphically. So let's go get our calculator up here. Hit the y equals. Clear out the previous problem, and we're going to go ahead and put in our x squared plus 8x plus 16. Okay, we're assuming that we did the arithmetic right to get to that point. That may not be a safe assumption, but we're hoping at this point in our mathematical career, we're pretty confident that we did that right. In other words, got it all set to equal to 0. Okay, let's go ahead and do a zoom and a 6 since we don't know any better. And sure enough, bada bing, bada boom, the graph comes down, hits the x-axis, bounces off like a ping pong ball, and keeps on going. So that is the typical vision that we see when we have a single 0. Let's go ahead and do the intersect routine. Let's go second calc number 5. And let's take a look at the first curve and the second curve here. Let's get a little Frogger guy down a little closer. So there's our first curve, there's our second curve, there's our best guess. And notice it comes back out with a little bit of spare change. It didn't get exactly to negative 4. And you think, oh man, did I do it wrong? Well, I don't know. Let's try it again. Let's go second calc number 5. And let's go first curve, second curve, best guess. And still coming out about there. But so it's actually, the problem is, give me one more try at this here. I just want to show you. It's really sensitive to your initial guess in this case. So first curve, second curve, guess. I should have moved them over just a wee bit. Sorry about that. Now it's stuck on it. But notice again, I got a slightly different answer this time. It's negative 4. It's just the calculator having some round off problems. If we round off, we're going to get negative 4. Okay, so we got to come in here and give a reasonable sketch of what we've got on our calculator screen. So this goes from negative 10 to 10 and negative 10 to 10, and our graph looks not quite unlike, but similar to that. When it's only a single point of intersection like that, the calculator has a rough go with figuring it out. So its routine is giving a bit of round off error. In fact, you may have gotten a different answer. You may have a different version of the operating system in your calculator. You may have got a slightly different answer than I did. But nonetheless, to any sort of reasonable estimate, x is equal to negative 4 here. And we could plug it back in directly into our equation, and we would see that in fact it does work there also. Okay, label my axes here and we will call it good. Hopefully this is pretty straightforward. Notice that when you get one, just back up here for a minute, notice that when you get a repeated factor in your factorization, that is a single point of intersection with the calculator or the graph. In other words, you get the same number twice.